Hello, everyone. Can you hear me? Can you hear me? Hello.
I can hear you.
Thank you. Good evening to all of you. Good to see four of you, Anna, Mandy, Monica, and Tristan. Thank you, and welcome for joining the session. And so basically what we are covering in this course, which is much more than this Harvard Business Analytics certification. And this is what they are going to cover in their certification. And you how much you have to pay? I think about $2,000, more than $2,000 is the cost for this certification. We are covering much more than that, and we are in next course we are going to cover other things. So you will have more knowledge from these two courses, 503 and 520, as compared to Harvard Business Analytics. If you go in that online Harvard Business Analytics complete 5-6 course of complete certification, then I think more than 50% is covered in these two courses. Other courses they offer in that, like leadership and business environment and such, but core analytics courses are, I think, one or two. So they do exactly same. Now let's start the module number 5, which is hypothesis testing. I hope you are enjoying the course, and this is the module number 5, is hypothesis testing. So what is hypothesis test? What is hypothesis? So let me start few points related to hypothesis testing, and then we will do on our Minitab, and then we will learn how to do and what we can conclude. So basically, hypothesis testing is a complete process, and complete process from getting an idea, formulating hypothesis, getting data, find test statistics, make decision, and revise your idea. So these are the steps in order to do hypothesis testing. Before going into hypothesis testing, I would like to make a point. What is hypothesis? What is the definition of hypothesis? Any idea? Any thinking? Any input? What do you understand by word hypothesis?
Educated guess?
Yeah, just any definition that you think would be correct for hypothesis. Only hypothesis, the word hypothesis. Any guess, like you said, any other? Actually, hypothesis is any statement or any assumption that you make about anything. And then statistically, through this process, you test it. So there are state the hypothesis to be tested, and all, collect data, make decisions, specify the decision rule, collect data, make decision, and take actions. So here there are two types of hypothesis. Let me start with one practical example, and then we will go from there. Just a minute. So I'm just using whiteboard. Let's say we are sitting together somewhere. I mean, I give this example, and I started giving this example since, this property or housing market bubble. Let's say you are located in a Spokane, South Hill, and we were talking on a coffee table that housing prices, mean housing prices in Spokane is South Hill is about $500,000. 500. So this is 500K. I said no, it is more than 500,000. You said no, it's about 500,000. Who is correct, you and me? I mean, we don't know. You are saying this, I'm saying against. Then okay, we decided to let's do through statistics. Let's whether you are correct or I'm correct. Let's check this who is correct. So this is first thing. Second thing, this is hypothesis, we made it. Okay, 500K. Second step is in this. At what percent confidence level? Let's say 5% significance level or 0.5 significance level. So this is decision rule. At 95% confidence level, we are going to check this. So this is the second thing, confidence. Third step in this, I mean, how we can check? We need to have data. Let's say data. Fourth thing, we need to do calculation. And I mean, we need to test, calculate the statistics. Fifth is we need to make decision. And sixth step is to take action based on decision. Who is correct, who is not correct. So these are the 5 major steps. As you know, that we check the hypothesis based on, in previous chapter, there are 3 important things. One is mean. One is, what is the second thing? Number 1 is mean. Number 2 is standard deviation or variance. Number 3 is proportion, as we know. So first, mean or average. So we just formulate this hypothesis based on mean housing prices, which is, there are also median hypothesis, which is not covered in this, but let's say we are talking mean average or average house price is 500K. Let me start. Okay, so first step is to write hypothesis, null and alternative hypothesis. So what is null hypothesis? What is alternative hypothesis? Null hypothesis is written in this format: H0 colon mu equal to 500K. Alternate is, I'm just giving one example. It is written H1 or HA. Either way, some books write H1 or some write, A. So you can use any symbol. Mu not equal to 500K. So this is null hypothesis. Why we give this null? What is the name? Why we give the name null? Null means no, zero. That means, what is the meaning of this? There is no difference between your assumption and the actual data, based on actual data. So basically, there is no difference between this 500K and actually coming from. Therefore, the difference will be zero. Whatever you are assuming and whatever statistically proving, both are equal. Therefore, difference will be no difference. The second option, it is not equal, means whatever is your assumption and whatever is coming from the calculation, both are different, which means not equal. So this is, therefore we give it null, means no, zero difference between your assumption and actually through statistics. So this is these are the steps. Let's do in Minitab. So we are doing only one sample statistics. This is one sample. Next course we will have 2 samples. So we are just doing one sample. So I'm just going to South Hill housing price. So I just write South Hill housing price. And let's say how many house we need to collect. You know from the statistics, what is the minimum size in order to infer something? As you know, minimum 30 or plus. So let as big as sample size, better is the result. So I'm just going to get 50 house prices. So I just go and I just generate the random numbers, random data, and where's
We're not seeing your mini tab right now, just the whiteboard.
oh, sorry. Just a minute. Thank you. I got engaged too much in. So, okay, here we go. Now, can you see this?
Yes, we can see it now.
Oh, thank you. So this is, I'm just going to have 50 house prices here. I go and I'm just randomly generating. So I go under data. Sorry, calculate, and I go random data, and I go under integer. Where is integer? Integer. And I collect 50 house data, store in C1. And I mean, as I know from my understanding, South Hill area where I live, the house prices starts about 400,000. 400,000. So 400,000, yes. It goes up to millions. So I'm just writing, about 650,000. Or, this is whatever data I have collected, it is in this range. So I have collected 50 houses data, prices here. Okay, now I need to check my hypothesis. So I go under statistics, basic statistics, one sample T. Why because I don't know the entire South Hill housing price standard deviation. I don't know. Therefore, I'm using one sample T. Now, here I go. I have the data in the row, and I select this data. I do this perform. What is my assumption? 500,000. How much? 500,000 is, yeah. Now we decided we are going to check this at 95%. So we make it. There are three options here. So first, equal, not equal. Second is less than. And third is greater than. What is the meaning? This is only writing the alternative hypothesis. We will talk about this later. This is writing. This is not null hypothesis. This is alternative hypothesis. So you can clearly see. Okay. Here we have different graphs, so we are not going to use. Now we get the answer after clicking this. Now you can see. So mu equal to 500,000. This is, you can see clearly the null hypothesis or alternative hypothesis that we wrote, that we started with. Then mean is 500 to, mean prices of our sample that we collected, 50 sample, is 526,751. Standard deviation is this. Standard error mean 95% confidence interval is 506 to 547. Now we come to the conclusion. Here, this is a t value and this is a p value. How we do it? So basically, if you remember, this is our, and 95% confidence here, this is 2.5 here, 2.5% here, and 2.5% here. And if we get in this range, we can say our null hypothesis is correct. Otherwise, we can say so. Let me see what is our t value for that. So I go under here graph probability distribution, and let me go with, and since it is t is large enough, which is more than 30, it will behave like a normal distribution. So I go under t, degree of freedom 49. shaded area, we need 5% and we need 5% and this is fine. What is the value we are getting? For minus 0.010 means it is -2 to +2. -2 +2. And here you can see. So this is, now let me clear this part to explain. So this is the value we are getting here. This is our t value. Now look into this. What is our calculated t value? I have to go there. 2.6. What is the meaning of that 2.6? Which is coming somewhere here. 2.6 is here, somewhere here, which is above the range. Then what will you say? So it is not coming in this range. If suppose we get a calculated value 1.9, so 1.9 would be within this. In this case, our null hypothesis will be correct. But since our value is coming here, what we say? Null hypothesis is rejected. Null hypothesis is rejected. Then automatically, if null hypothesis is rejected, what will be the case? Alternative hypothesis will be accepted. So this is correct. What is correct? This is correct. Means it is not 500,000. It is not 500. It is more than 500,000. So this is the other way of checking. You know, if you don't want to check with t value, there's a p value through which you can check whether your hypothesis is correct or not. What percentage of level? You took 0.05%. This is, we are checking 95% confidence. We are checking alpha equal to 5%. And p value is less than, or you know, it is less than 2%. It is 1.2%. So p value, what is p value? 0.012. So this is thumb up rule. Please remember, if you don't want to check this way, this is also way of checking. If p value is greater than equal to alpha, then what happened? Then you say H0 is accepted. H0 is accepted. This is tick mark. If p is less than alpha, p is less than, this is 5% and this is 1.2%, then in this case, H0 is rejected. So this is the two way. Why why this is happening? The reason is very simple. Because you can see this part. So this is 5%. You know, it is getting rejected at 95%. But you look, you know, this is this red part where, so what is the, you know, I can demonstrate it in different way. T value is 2.6. T value is 2.6. Let me see at what percentage this is coming. So statistics, graph, probability distribution. Okay, I think I need to clean this. And this is correct. And here we go. And now we need to put X value. X value is 2.6 plus 2.6 and minus 2.6. So I need to put two value minus 2.6 to 2.6. Look into this. So here, up to what level this is going? 98.77. So if you say if this has to be accepted, means this hypothesis, we have to go about 99% confidence. You can look into this. With this range, 2.5 2.5%, 2.5% both sides. So this is coming in rejection. When if this has to come in acceptance region, it has to be more than, I mean, about 99%, then only you can accept the null hypothesis. So, so this is another way of checking p-value. Let's say, so this is number one thing. Now, what happened if I increase this confidence level? So I go and I do the exact same thing, and I go and do one sample T, and option, I do 99%. I hope this is getting recorded. And then look into this. I did 99%. Here you can see the result. The same result is coming, but you know, the p-value is more than 1% as per alpha rule, and you know, t-value is 2.6. P-value is greater than alpha value. P-value is coming 0.012, and alpha value is 0.01. So this is greater than, and therefore null hypothesis is accepted. So at 99%, we can say 99%, you can say that the price of Spokane South Hill area is about, mean price is about 500,000. But 95% you can't say. So this is the hypothesis testing. If you increase there's two ways to do this. If suppose your value is increased little bit here and there, your hypothesis can be accepted and rejected. If your confidence level is increased or alpha value increase or decrease, your hypothesis can be accepted or rejected. Based on this, there are two errors which are there in this. So null hypothesis, alternative hypothesis. So basically, this is type 1 error and type 2 error. Means rejecting the null hypothesis when it is true. Because you selected wrong decision rule, because you changed, let's say 99 and 95 that we just see. Basically, you are just selecting a different rule, or you know, because probability of alpha, level of significance, instead of 95 or instead of 99, you selected 95 and your hypothesis is rejected. That is called type 1 error. Type 2 error, failure to reject null hypothesis when it is false. This occurs with beta probability. And this occurs when you selected the wrong benchmark value, like I selected 500,000 here. So these are the two error which can be possible when you make your decision. So H0 is true and you reject because of confidence interval or because of alpha value. This is called type 1 error. And H0 is true, you fail to reject. This is correct decision. H0 is false and reject H0, which is correct. And H0 is false and you fail to reject, which is type 2 error because of. So this is type 1 and type 2 error. So here, you know, it has different power tests, which we are not covering, but this is a summary about that. So critical, now we have three different types of hypothesis. This is just, we spoke about two-tailed test, which is equal or unequal. What about the question is talking about more than or less than? Then also we have the option in the Minitab. Let's say this is the thing, and here I go under this basic, and I go one sample T. Nothing is changed. Here I'm changing one option. One option I'm changing, and here I'm just changing as usual 95. These are alternative options, not null option. Here I'm saying mean is greater than hypothesized mean, which is in our case. It is saying you said 500,000, I said more than 500,000. Okay, so this is alternate. So null, what is the null hypothesis? Null hypothesis says less than or equal to 500,000. Alternative says opposite of that. So here, okay, I go okay, and I do. And now look into this, exactly the same value. P value is this. So our here null hypothesis says, so here null hypothesis is mu is less than equal to 500K, and alternative is saying mu is greater than 500K, greater than 500K. So which hypothesis is P? Again, based on alpha value, again, based on that, we are proving this null hypothesis. This is, so this is not true. This is correct. Now, third option, look into the third option. I go basic statistics, one sample, and I'm selecting option. It is, you know, somebody is saying it is less than 500,000. Okay, let me do this. And here you can say no. So what is the null hypothesis in that case? Let me remove and that. So null hypothesis saying mu equal to H0 500 equal or greater than, I mean, I have to put both sign like this, and null equal to mu and less than 500. Now you can clearly see which hypothesis based on, because t value will remain same, p value you can see. P value is, so this hypothesis is proved. This is, I mean, once it is proved, automatically this is rejected. So based on p value, you can calculate, you can make your decision. So these are the three options: left tail test, right tail test, when to choose, and okay. So now similarly we can do for pi or proportion, and same rejections based on same situation. For example, any event which is happening, and if you get the data and make sure that you know that data, and based on that you can, let's say right now if attending class, I say 50%, usually in my class when I'm doing online class, 50% are ratio of male and female in my, or 50% males are there in my class and 50% females are there. Okay, this is like online class. When I look into this, if I take the data, let's say I'm just taking a data of this class and I'm just taking a proportion. So attendance, I'm just writing here. And for male, or for female, I'm just writing 1. And so Anna, Dana, and Mandy. So I'm just writing, related to this. Monica, Stewart, and Tristan. So this is the data as of now. 6 of you are there. I'm the 7th one. So this is the data. Usually I say in my class at 50. Now let me check. Since this is very small data, when we do, big, then I can do. So statistics, basic statistics, 1 proportion. And I will have the data from attendance, perform, hypothesized proportion, usually 50-50. Option, proportion I'm just using. And now you can see first is proportion is equal to 50% here. And okay, and alternative hypothesis p-value is getting. Now here, this is giving us exact value. We have to check one option, which is right here. Since, option exact or normal approximation, if you have sufficient data points and you can. So if you see the normal, then you can get the z value, you can get the p value. Since data is very small, only 6 of the u, but if I take, like 100 of the students, I will get the, clear picture. With 6, I can't get. So for normal approximation, p value is this, z value is this. What is the meaning of this? So we can conclude there's no difference, 50%. This is by default, it is coming 50%. Though, sample is having only 6 students here, but based on 6 students, if I take a normal approximation, because p value is greater than alpha value. Now, so again, the same decision rule, critical rule, all this. Type 1 error I already spoke about. Testing a mean known population variance. This is another important concept that you remember, and you remember from the past section. When you know the population standard deviation, always use one sample z test, because here, if you see the summarized data, sample mean, sample size, population standard deviation. When population, read carefully and do it. And here you can see this option, one sample t, and let me do. Here you can see standard deviation. This is sample. Sample means sample size. Here we don't have the population standard deviation. So this option, when do we use t? When do we use z? You can understand this. If entire population standard deviation is given, then you can use z. So here, you can simply calculate this z value, and you can, this is a step-by-step process. Null hypothesis, H0 equal to mu less than equal to 200, and alternative is this. And keep going and calculating, making a decision. So p-value approach, this is, I already explained. If p-value is greater than alpha value, null hypothesis accepted. Or in other technical word, we fail to reject null hypothesis. This is a technical word, but simplicity, for simple reason, I'm just explaining this way. You need to see 2-tail test, 1-tail. So this is exactly the same thing. When do we use this test or that? If sigma is unknown, sigma is a population standard, then use t-test. And I already explained this. So confidence versus hypothesis testing. So you can clearly see testing a proportion. I just explained this. Remember, when do we use normality? This is the condition that we learned in previous chapters, that n pi equal to greater than 10, and 1 minus pi is also greater than equal to 10. If this condition fulfilled, then you can use normal approximation, otherwise use the exact calculation. And yeah, so for pi, same thing. And last thing, for mean and proportion, the last option is for variance or standard deviation. For that purpose, we do chi-square test. What we do? Chi-square test. And I think somebody asked about the chi-square question. One question is given about degree of freedom. Then you just go and run the graph here, probability distribution, use, and instead of that, you do chi-square test, degree of freedom. If sample is 16, use 15. Shaded area, I just, for 5%, use this. And you can get upper value, you can get lower value. So I'm just giving the answer probably of the question. So this is upper cut and this is lower cut. So this is a chi-square distribution to check standard deviation is within their range, or and variance is within the range. So this is for checking the standard deviation and variance hypothesis. So this is about this module. And you can do a lot of, you can benchmark your salary and you collect the salary from Indeed, whether it is in your salary is more than, less than, or you can, or within the benchmark, or your housing prices or your house price. You can collect the data from Zillow or Realtor or Redfin or any website, and you check your house price, and many such problems can be solved. So this is hypothesis testing. We are just doing one sample. Any question related to this, please don't hesitate to ask me. If you don't have any question, I would like to say have a wonderful night and
Thank you for your time.
most welcome.
Thank you so much.
Most welcome.
Thank you.
Most welcome. Bye-bye.
Thank you. Have a good night.
Bye-bye. Good night.